Right, so we are going to do Pythagoras theorem, but you might be thinking, well, what's the big deal about Pythagoras theorem? Why do I have to bother about right angle triangles and stuff? Well, it can be useful in all sorts of unexpected situations, especially when you're in love. Well, for example, Romeo and Juliet found Pythagoras theorem really useful. You don't believe me, do you? We'll see in a minute how. But before that, we had to cover some basic stuff about numbers. We just have to refresh your memory. What is the square of a number? 3 squared is 9. It is what you get by multiplying 3 by 3. So it's 3 times 3. It is not 3 plus 3, 6. No, that's not 3 squared. So 5 squared is 5 times 5, which is 25. And 10 squared is 10 times 10, which is 100. So that's the square of a number. Right. So let's get back to Romeo and Juliet. So here's Juliet. This is a window. Clearly it's a bit high. And this is the curb there. And so Romeo has to find a way to reach Juliet, and he needs something. He can't just jump up there. So he needs a ladder. So now he has to calculate the right size. If it is too big, he's not going to get to the window. And if it is too small, that's not good either. So he has to calculate it. But Romeo couldn't remember exactly how to calculate it. He kind of remembers learning something in school about right angle triangles. So he said, okay, so this is a right angle triangle, is it? Yes, because it's got a right angle here, because that's horizontal, this is vertical. So the right angle triangle, he kind of remembered you do some calculations. If you know two sides, then you can do some calculations to get the third side. So this, her window is 4 meters high, and this thing, the curb, is about 3 meters from the wall, and he needs to rest the ladder against the curb so that it doesn't slip. So it has to be exactly there. So it's a right angle triangle, you know, this side and that side, but the ladder is going to be the longest side, which is also known as the hypotenuse. You might be wondering, well, why can't he just use an extendable ladder? He doesn't have to do any calculation, just adjust the length and he can get there. Well, he couldn't do that for two reasons. One, Juliet didn't find them very romantic. She wanted a proper wooden ladder. And the other thing is, if he uses an extendable ladder, then Juliet, every time her window washer comes up, she might think it's actually Romeo. So she didn't want the confusion. So Romeo had to do the calculation now. So he's got the triangle, and he has to find the missing side, which is a hypotenuse. He kind of remembered the way to find the hypotenuse is to do something with the other two shorter sides. You square the sides. He kind of remembered, you square this and you square that, add it up, and he thought, oh, that must give me the length I need. So he tried it. He squared it. He got 9 when he squared 3. He squared 4. He got 16. He added them up. He got 25. And he said, okay, so I just need a ladder that is 25 meters long. Well, that didn't work out that way. Obviously, that's a bit too big. So he went back and rechecked his calculations. Then he remembered, now, when you square the two sides, two shorter sides, that doesn't actually give you the size of the hypotenuse. It gives you the number that you will get by squaring the hypotenuse. So square of this plus square of this doesn't actually give you the hypotenuse, but it gives you the square of the hypotenuse. So we still don't know the length of the ladder, but we know when the length is squared, the answer will be 25. So what is a number which, when squared, gives you 25 as the answer? That number by itself must give us 25. 5 is the number, because 5 multiplied by itself gives us 25. Another way of writing this is square root of 25 is 5. Because when you put the square root of a number, we are simply asking, what is a number which, when multiplied by itself, gives us this as the answer? It's 5. So he got a ladder that is exactly 5 meters long, and it worked. So that is the introduction to Pythagoras theorem. Thank you.